So we're going to go ahead and deal with some word questions. They deal with ratio and rates, and I think we're going to get into percentages as well. But let's go ahead and start with something you already know. A lot of people have no idea that there's a formula that relates distance, rate, and time. It's known as the DIRT equation, is what I've heard it referred to. And what's funny is I didn't really learn that in a math class. I actually picked that up in one of my science classes. And this is kind of what my teacher said is, look, if you do 30 miles per hour for 5 hours, could you figure out how far you've driven? And you're like, well, yeah, 30 miles per hour times 5. You would go 30 times 5 and get 150 miles, right? Well, what did you do? You took that 30 miles per hour, which is a rate. You multiplied it by 5 hours, which is a time, and that gave us a total distance. You're like, okay, so where's DIRT? Well, this is, like I said, for years I was just did rate times time equals distance, totally fine with that, was able to work through all of them. And then in my science class, somebody said, look, that's a DIRT equation. Distance equals rate times time. DIRT, D-R-T. I've even had some students, and I thought this was pretty clever, and they said, look, you can even take the equal sign if you're having a hard time remembering where it goes. If you were to put a line through it, it literally spells the word D-I-R-T, dirt. So anyway, I'm just going to do this, but it's DIRT, distance equals rate times time. Well, why does that help? Well, because we're going to be starting with ratios and rates, okay? So if I took D equals RT, which is one of our equations we should know, I can get basically several other equations from this. For instance, what if I wanted to solve for just a rate? Could we do that? Well, yeah. The rate is being multiplied by time. We can take both sides, divide by the time, and we get what? Rate is distance over time. So when we're dealing with these ratios and these rates, we're going to be dealing with sometimes distance over time. We also have different rates that we get. If I buy gas, I get it's, dollars per gallon. So we have, if you go and you buy food, now they list the price. It would be dollars per ounce. They'll list that. Or they'll put dollars per 1 gallon as well. But the idea is that they start putting these things so you can start getting a rate or a ratio to help you understand what it is. So let's look at our first example. At Smith's Bike Rental, it cost $18 to rent a bike for 4 hours. How many dollars does it cost per hour of bike use? Okay. I could sit there and I could come up and go, okay, it'll be rate times time is equal to the cost. Okay, so I could set up a new equation. Cost is equal to whatever the rate is times the time that you use it. But it's easier just to say, no, we're dealing with just the rate. So how would I figure out that rate? Well, they give you a hint. It's cost per hour. So if I divide this, notice the rate is what? Cost over time, or cost per hour. So really, to solve for this rate, all I have to do is take that cost and divide it by the number of hours. And this is one where we probably wouldn't want to leave that as a fraction. So we would divide 4 into 18, and we would get that the rate would be, what is that, 4.5? And 4.5 what? Dollars per hour. Color printer prints 7 pages in 3 minutes. How many minutes does it take per page? They want the minutes per page. I don't need to set up a DIRT equation, or this one was a KURT, I guess, with a C, I don't know. But the idea is I don't need to set that up. They're asking for the rate. And they said minutes per page. So what goes on top? Minutes per page. What numbers did they give us? 3 minutes, 7 pages. Okay, no, I think that's right. I had to think about it for a second. We're not going to leave this as a fraction, so we're going to divide the 3 by 7. So I'm going to need a calculator for that. 3 divided by 7. 0.428, probably to the thousandths. So 0.4285 becomes 0.429. Make sure I did that right. 428. Yeah. So 0.428 or 429 what? Pages per minute. And that would be the rate of that printer. Raphael bought 29 pounds of rice for $12. How many pounds, I don't know why that was missing the S, of rice did he get per dollar? What do they want? Pounds per dollar, right? So the rate will be pounds per dollars. 29 divided by 12, 2 point something. $2.416. How about we round that to 2.4? Well, we're dealing with money, so we probably do it to the nearest penny, and they'll tell you how to do what to round to in the homework. But we're looking at about $2.42. No, 2.42 pounds per dollar. Deborah runs 5 miles in 29 minutes. How many miles does she run per minute? They're asking for the rate, miles per minute. We are going to do this. Take the miles per, divide by 29 minutes. How about 0.1724? So we'd round that to about 0.172. What? Miles per minute. And that would be her speed. The cost of an orange was 85 cents a pound. Cheng bought 3.8 pounds. Find the amount he paid. Notice this time they didn't ask you to find a rate. They asked you to find the amount. This is still a version of dirt, but we're not dealing with distance, rate, and time. We're dealing with cost. The cost will be the rate times the amount. So the rate is what? Dollars per pound times pounds. Quantity. Okay? So the cost is equal to the rate times, let me scoot that over, the quantity. It's just a new version of dirt, but it's still the same idea. So the cost we don't know. We know the rate is what? 85 cents per pound times we bought 3.8 pounds, and that will give us the cost. So 0.85 times, what did we get? Was it 3.8? $3.23. Tree in Trey's background grows, apparently a constant rate, about 0.6 meters each month. The tree is 2.82 meters tall. For how many months has the tree been growing? This one's different, right? What do we have? Well, we don't have distance. We have height, right? So it's going to be the height is equal to the rate times the time. Do we know the height of the tree? Yeah. That was 2.82 meters. Do we know the rate of the tree? Yeah, it was growing 0.6 meters each month times what don't we know? We don't know the time. So we need to be able to solve this. We need to be able to solve this equation. Since time is being multiplied by 0.6, we divide both sides. That's the idea of inverse operations. So the time is equal to 28.2 divided by 0.6. $47. So the time is 47 what? Months. Donna runs 4 miles in 30 minutes at the same rate. How many minutes would she take to run 10 miles? There's two ways to do this. I'm going to show you kind of a way that I've seen a lot of students do first, and I'll show you kind of the way that I was taught. Both are right, and depending on what makes sense to you, you'll be able to do either. But could you figure out Donna's rate right there? Well, 4 miles in 30 minutes. So could you figure out her rate? Would be what? Miles per minute. So could you take 4 miles, divide it by 30 minutes, and it ain't going to be pretty, but it's about 0.133 miles per minute. Well, then how long would it take for her to run 10 miles? Well, I can take 10 miles and go, the distance is 10, is her rate, times what time? So I can divide the 10 by 0.133 and get the time. 10 divided by 0.133. About 75.18, 75.19. So that's how many minutes it would take her. That is something that I see a lot of people doing when they get to these questions. In this situation, I actually think it's a little harder, but it does work. You figure out what her rate is, and then you figure out, well, how long would it take for 10 miles? The other option is this. I can set up ratios. See, if her rate is 4 miles over 30 minutes, I can set that equal and figure out what time would it take for her to do 10 miles in X minutes. See, what I can do is I can solve this. I can set up a ratio and say miles over minutes should be equal to 10 miles over however minutes this takes. So then what would we do here? Well, we would cross multiply this and we would divide. So I could multiply both sides. I want to clear out the 30 and the x, so I'm going to multiply both sides by 30x. On the left side, the 30 goes away. On the right side, the x goes away. So I'm left with what? 4x is equal to 30 times 10, 300. 300 divided by 4. About 75. So this is actually a little more exact. And the reason is because I rounded off some stuff here. So if I had taken that 10 and I had divided it by the exact decimal, I took that 10 and I divided it by that previous answer, I went up and grabbed that, then I would have gotten exactly 75. So there's a little round off there when you do different formulas. But I would be fine with either method. They're going to mostly want you to set up these rates or ratios, but you don't have to. But I'm going to go ahead and focus more on the ratio style. And then if there's one where it seems more applicable to do the left format, I'll do that as well. But I'm going to go ahead and keep setting up the ratios. Okay. Petroleum motor oil is a combination of natural oil and synthetic. It contains 7 liters of natural for every 5 liters of synthetic. If we use 375 liters of synthetic oil, how many liters of petroleum oil will be made? Okay. So what we can do is we can set up a ratio. They give me 2 numbers here, the natural oil and the synthetic oil. So I can set up 7 liters of, I'm going to set up a ratio of the natural to the synthetic. So 7 liters of natural over 5 liters of synthetic is equal to, they gave me 375 liters of synthetic. Where will that go? Well, natural goes on top, synthetic goes on the bottom, so 375 goes on the bottom. What goes up here? Well, this is what we don't know. How many liters of natural oil are we going to use? I don't know. Let's call that X. We could solve this. We could cross multiply it. I wouldn't this time. I would just undo this division. I would multiply both sides by 375. And what would that do for me is 7/5 times 375 is I can get to the answer a little faster. So you circle this, you type it in, and then they mark the question wrong. That's really annoying. You have to be careful with these sometimes. What did we just solve for, right? It was natural over synthetic. We found out how much synthetic we used. That's not what they asked. Did I mess that up? Sorry. We found out how much natural oil they used. That's where our X was. So we basically used 525 liters of natural. The question is, how much oil total are we going to use? Well, I'm going to use 375 liters of synthetic plus 525 liters of natural adds to 900 liters total. The other option for this, because I think this is the way most of us would need to do it, but the other option with this is that I could set up my ratios different. What I can do is I could set up, instead of the natural to the synthetic, I could set it up as total over synthetic. Why? Because that's what they want to know at the end. They want to know how many liters of the total oil we're using. So if I use 7 liters of natural oil and 5 liters of synthetic oil, that gives me a total of 12 over, how much synthetic did we use? 5 is equal to the total over 375. Most of us probably wouldn't solve it this way, but that's kind of the beauty of ratios, is we can set up different ratios to solve it differently. So if I do the total over the synthetic equals the total of the synthetic, then what I'll do this time is my X will be the total. Okay? So basically, what is 375 times 12 over 5? Notice this time, it went straight to the 900 because our ratio was set up for the total. Most of us, I wouldn't expect to do it this way, but either way, you should get the same answer. Okay? Now let's go ahead and do some more questions with percents. The price of a gallon of unleaded gas was $2.78 yesterday. Today the price rose to $2.84. Find the percentage of increase. Round your answer to the nearest tenth of 8%. Okay? We already talked about percents before. The idea that we said I didn't really like the is over of. So what I did is I figured out that if I take the percent times the total, it gives me the part. The problem is with when we have markups and markdowns, the total is not always what we're looking for. So we do have a couple of the versions of this. I can have the percent times the original price will give us the markup or markdown. So if we know the percentage, then I can figure out what the markup or markdown is. I think that's the one we're going to go ahead and use this time. What they want to do is the percentage of increase. They want to figure out the percentage of markup. Okay? So basically, we don't know the percent. That is our X times the original price. What was the original price of the gas? Well, that was the $2.78. Is equal to, since this is the percentage of markup, this will be the amount of markup. It will not be the $2.84. That is not the part. That is not the markup. It didn't get marked up $2.84. It got marked up 6 cents. How did we figure that out? Well, it was $2.78. It's $2.84. Take the difference, $2.84 minus $2.78, and it was marked up 6 cents. That is the markup. So what do I do now? Well, I can figure out what that percentage is by dividing both sides by 0.06 divided by 2.78. There it is, sorry. .0215. So to the nearest tenth of a percent, if I move it twice, that gives me 2.15%. Tenth of a percent means that they're going to want 2.2%. So it was about a 2% or 2.2% markup. Suppose that an individual has a body fat of 18.3% and weighs 137 pounds. How many pounds of weight does this individual is made of fat? It's not very nice, but this is still a percentage question. Is this a markup? No, they gave us a percent and they gave us a total amount. So I'm looking at this and going, hey, percent of total equals part. So I'm doing percent times total equal to the, what's the percentage? 18.3%. So what do we bring down here? As a decimal, move it twice. 0.183 times, what's the total weight? Equals the part. 0.813 times 137. I messed that up. 0.183, sorry. I was like, that is a lot of fat. 183 is 25.071. So to the nearest tenth would be 25.1 pounds of fat. Blech. A bicycle has a list price of $711.99 before tax. Sales tax rate is 8.75. Find the total cost. Well, I can do the percentage times the total. So I can take the total and multiply it by 0.0875 times the total. And what that will do is that will give me what the tax was. That will give me the part. 0.0875 times $711.99. $0.62.2991. 62.2991. So there's no way they're charging me 0.2991 cents. They'll probably charge me, rounding that up to 30 cents. So is that the cost of the bike? No, that's just the part. That is the kind of like the markup. The percent times the original amount. It got marked up 62.30 cents with the tax. So how do I get the total cost? $711.99 plus the tax. So $711.99 plus $62.30. We're looking at $774.29. That is an expensive bike. Is our total cost. If you're clever with this, you can actually multiply it by 1.0875, and that will give you the total cost right off the bat. But I think most of us would figure out what the tax is and then add it to it. So we have some options there. Book sold 36,600 copies in its first month. Suppose this represents 8.6% of the sales made to date. How many copies have been sold to date? Well, I'm looking at a percent times a total, learn to spell someday, is equal to a part. They gave me the percent. 8.6% becomes times, was the 36,600 the total number of books? No, that's what they want us to solve for. That's what we don't know. That's the x is equal to what the 36,600 is it's the part. It's the amount that we've sold for that month. It is the 0.086%. So to solve for x, we divide by 0.086. So 36,600 divided by 0.086, 42,581. That is the total books sold. Salesperson earns a commission, $576 for selling 3,600 in merchandise. Find the commission rate. Okay, so this time they want us to find the rate or the percentage. Depending on your percentage, I encouraged you before to know that the percentage is part over whole. I can just take 576, divide it by 3,600, turn that into a decimal to a percent. I got my answer. If you know how to do that, you can solve these types of percentage questions really quickly. If you're not sure, you go back and say, okay, percent times total or original, 3,600, should equal the part 576. How will I solve for the x? Well, x is equal to 576 over 3,600. .16. This person is not working for 0.16% commission. Remember, that is a decimal. So to turn that into a percent, we move it twice. So really, a 16% commission. So that's most of the hard kind of percentage questions. I'm expecting you to work through them, but this actually has real life application. A lot of times we solve equations and we do things and we're like, how would we use this in that everyday life? I can't promise you will with all that. This is stuff you should know as a consumer. You should be able to find percentages, markups, decreases. Make sure you don't get ripped off on these things. Now for some easy stuff. Here's a table A group of 200 middle school students were asked whether they prefer playing video games or watching TV in their spare time. The genders of the students, their responses are reported in the following table. What percentage of the students are boys? It's hard because they don't give us that. They're actually missing something in this table. So what I'm going to do is I'm going to pull the table over here real quick, and I'm going to do something that we really need to make sure we do whenever we do this type of question. This shows up a lot in statistics. We need some totals. For instance, how many total people played video games? There were 30 boys, 54 girls. Adding those totals to 84 total people there. How many watched TV? 76 and 40. Adding those together, about 116. How many total girls are there? Well, 30 and 76 totals to. And how many boys were there? 54 and 40. How about 94? And I also always like to check this. I call this the total because this is just the total that played games, the total that watched TV, the total girls, the total boys. What's the total of the entire group? Well, they told it to us, but you should be able to check. 84 plus 116 is 200, and 106 plus 94 is 200. So it's a good way of checking my other totals that this total should be 200 either way. So what percentage of the students are boys? Well, I already encouraged you to think of percentage as what? Part over whole. What part are boys? There are how many boys total? 94 boys out of our total 200. 94 out of 200 is 0.47. That is not the percentage of students that are boys. That is what? 47%. If you'd prefer to set it up as percentage times total is equal to the part, you can solve it that way. I don't. Not when I get to these types of questions. What percentage of the students prefer playing video games? Well, how many students prefer playing video games? Well, there were 84 of them. That is the part out of the total 200. That ends up being 0.42. So what is that as a percentage? 42%. What percentage of the girls? The girls prefer playing video games. Well, this time, I want to know what percentage of the girls prefer playing video games. How many girls played the video games? 30. That is our part. Our part is the 30 girls that played video games over what is our total. It's not 200 this time because I'm not looking at the entire group. They want to know what percentage of the girls. I'm only looking at the girls. So this total down here is the total for the girls. How many girls were there total? So there were 30 girls that played video games out of the 106. I'm going to need a calculator for that. .283. So 28.3%. What percentage of the boys preferred playing video games? Well, how many boys played video games? The part is 54 out of, not 200 this time, because I'm not doing percent of the students. I'm doing the percentage of the boys. So the total boys would be 94. 54 out of 94. .574. Or 57.4%. So what does this say? Well, I could say about 42% of the students preferred playing video games. 47% of the students were boys. 28% of the girls liked playing video games, and 57.4% of the boys liked playing video games. So we can make inferences and statements about these percentages. I think these are easier because we're just setting up part over whole and finding percentages. The price of an item has risen to $186. Yesterday it was $120. Find the percentage of increase. If I go back to the beginning, we talked about two types of percentages. Beginning of the percentages right here. This is a percent times original equals the markup or markdown. Okay? We don't know the percentage. That's our X. Times. What was the original price? Well, it's risen to 186. Yesterday it was 120. It was 120 originally. Is equal to, what is the markup? Well, it went from 120 to 186. So 186 minus 120, it was marked up $66. Something that irritates me is I will have a lot of people go, oh, it got marked up $66, so that is 66%. That is not true. $66 is not always 66%. Okay, it's how much was it marked up from the original. So now I divide by the 120. What is 66 divided by 120? .55. So it was marked up what? A 55% markup from the day before. We just did a lot of examples there with the percentages. This book has some of the best examples to show you where we actually use percentages. We're not just doing them for the sake of doing them, but we're actually finding percentages that I think actually have application. So go through this, try to understand it. This is not something we should just be able to get right. This is something you should be able to pull out your calculator phone in real life and calculate some percentages for real life applications.